When NASA's deep space sensors detected an unprecedented seismic pulse from the moon's core, renowned physicist Michio Kaku issued a stark warning that sent shockwaves through the scientific community. This mysterious signal, originating from deep within our celestial neighbor, challenges everything we thought we knew about the moon's geological state. Today on Sci and Why, we're unveiling the discovery that has top scientists on edge, and exploring why Kaku believes this could fundamentally change our understanding of the moon, and potentially impact Earth itself. The discovery that shook science. NASA's most sensitive instruments detected something impossible, a seismic pulse from the moon's core that shouldn't exist according to everything we know about lunar geology. The discovery began when NASA's Lunar Reconnaissance Orbiter and ground-based seismic monitoring stations detected an unusual signal emanating from deep within the moon's interior. Unlike the typical moonquakes recorded since the Apollo missions, this seismic activity originated from the lunar core itself, a region scientists believed had been geologically inactive for billions of years. The signal displayed characteristics that defied conventional understanding of how planetary cores behave in their final cooling stages. Dr. Renee Weber, from NASA's Marshall Space Flight Center, who leads lunar seismic research, described the readings as unprecedented in both their origin and intensity. The seismic pulse lasted several minutes and registered on multiple monitoring systems simultaneously, ruling out instrument error or external interference. What made this discovery particularly alarming was its timing, occurring just as NASA prepares to return humans to the moon through the Artemis program. The implications extend far beyond academic curiosity, potentially affecting the safety and feasibility of future lunar missions and permanent settlements. Michio Kaku's urgent warning. When one of the world's most respected physicists issues a public warning about lunar seismic activity, the scientific community takes notice. And Michio Kaku's message was unmistakable. Theoretical physicist Michio Kaku, known for his work on string theory and science communication, responded to NASA's findings with unprecedented urgency. During recent lectures and media appearances, Kaku emphasized that this seismic signal represents more than just scientific curiosity. It's a potential warning sign that humanity has overlooked for too long. We're witnessing the moon's core in what may be its final gasps of geological life, Kaku explained. But these death throes could have consequences we're only beginning to understand. His concern stems from the signal's implications for lunar stability, and its potential impact on Earth-Moon gravitational dynamics. Kaku pointed out that any changes in the moon's internal structure could affect its mass distribution, potentially altering its orbital characteristics over geological timescales. He stressed that while these changes wouldn't be catastrophic in human terms, they could accumulate over thousands of years to produce significant effects on Earth's climate and tidal systems. Kaku's warning has prompted increased funding for lunar seismic monitoring and accelerated timeline for deploying advanced instruments on the lunar surface. The moon's hidden internal structure. Beneath the moon's familiar face lies a complex internal structure that scientists are only now beginning to understand, and it's far more active than anyone expected. Modern research has revealed that the moon's internal structure resembles Earth's in miniature, featuring a solid inner core surrounded by a partially molten outer core. The inner core measures approximately 240 kilometers in radius and consists primarily of iron, while the outer core extends to about 350 to 360 kilometers from the moon's center. This structure was confirmed through analysis of Apollo seismic data and recent gravitational studies conducted by NASA's Grail mission. Billions of years ago, this core system generated a significant magnetic field, evidence of which exists in lunar rock samples brought back by Apollo astronauts. As the core cooled over geological time, this magnetic field weakened and eventually disappeared, leaving the moon without the protective magnetic shield that guards Earth from solar radiation. However, the core didn't simply shut down, it appears to be experiencing final phases of activity that modern instruments are now sensitive enough to detect. The recent seismic pulse suggests that the moon's interior is still undergoing significant changes, challenging the long-held assumption that our satellite is geologically dead. AI reveals hidden lunar secrets. Advanced artificial intelligence has uncovered hidden signals in 50-year-old Apollo data, revealing that the moon has been whispering secrets to us for decades. We just didn't know how to listen. Scientists at NASA's Jet Propulsion Laboratory have been feeding Apollo-era seismic data into modern machine learning algorithms, producing revolutionary discoveries about lunar internal activity. The original Apollo seismometers, deployed between 1969 and 1972, recorded thousands of moonquakes, but analysis techniques from the 1970s could only scratch the surface of what the data contained. Today's AI systems can detect patterns and anomalies that were impossible to identify with vintage technology, distinguishing between genuine lunar activity and instrument artifacts with unprecedented precision. Dr. Sari Nunn, who leads the AI analysis project at JPL, describes the process as having a conversation with someone for 50 years, and suddenly realizing you've been missing half of what they've been saying. The AI has identified entire categories of seismic events that previous generations of researchers completely missed, including subtle signals that may have been precursors to the recent core activity. These discoveries suggest that the moon's interior has been more dynamic than previously thought, with ongoing processes that we're only now beginning to understand through advanced computational analysis. The shrinking moon phenomenon. The moon is actually shrinking before our eyes, and this contraction is creating dangerous fault lines that could threaten future lunar missions and settlements. As the moon's interior continues to cool, the entire satellite is contracting in volume, causing its brittle crust to wrinkle and form ridge-like features called lobate scarps. Some of these geological formations are remarkably young in astronomical terms, as recent as 200 million years old, indicating that this shrinkage process continues today. Dr. Thomas Waters from the Smithsonian's National Air and Space Museum has identified thousands of these thrust faults across the lunar surface, with many concentrated in the South Polar region where NASA plans to establish its Artemis base. The shrinking process creates internal stresses that can trigger moonquakes, some registering up to 5.5 on the Richter scale and lasting over 10 minutes. Unlike Earth's earthquakes, which typically fade quickly, moonquakes can continue reverberating for hours due to the moon's dry, fractured interior structure. This ongoing geological activity poses significant risks for future lunar infrastructure, as the moon's surface consists of loosely consolidated regolith that becomes extremely unstable during seismic events. The recent core signal may indicate that this shrinkage process is accelerating or entering a new phase that could increase seismic hazards for lunar explorers. Implications for Artemis missions. NASA's plan to return humans to the moon faces an unexpected challenge. The lunar surface may be far more seismically active than mission planners anticipated. The timing of these seismic discoveries coincides with NASA's ambitious Artemis program, which aims to establish a permanent human presence near the moon's south pole by 2026. The same region targeted for lunar bases happens to be particularly vulnerable to moonquakes and landslides, according to recent geological surveys. Dr. Nicholas Schmer from the University of Maryland warns that the moon's surface material, billions of years of pulverized rock from asteroid impacts, creates conditions where shaking and landslides can occur very easily. The planned Artemis base sites lie near several active fault systems that could pose serious risks to lunar infrastructure and crew safety. SpaceX's Starship human landing system, standing over 110 feet tall, with a relatively narrow landing footprint, could be particularly vulnerable to seismic activity. The recent core signal adds another layer of uncertainty to mission planning, as it suggests the moon's internal dynamics may be more unpredictable than previously thought. NASA has responded by accelerating development of the Lunar Environment Monitoring Station, or LEMS, a sophisticated seismometer suite designed to continuously monitor lunar seismic activity and provide early warning systems for future missions. The moon as Earth's cosmic stabilizer. You know, the moon doesn't just light up our night sky. It actually acts as Earth's gravitational anchor, preventing our planet from wobbling chaotically and, well, maintaining the stable climate that allowed life to flourish. The moon's gravitational influence goes way beyond just creating ocean tides. It fundamentally stabilizes Earth's axial tilt at about 23.5 degrees, and that's what gives us our predictable seasons. Without this lunar anchor, Earth would wobble chaotically like a spinning top, and that would lead to extreme climate swings, making complex life nearly impossible. Michio Kaku often points out that Earth is unusually stable for a planet its size, with the moon acting like, training wheels on a bicycle to prevent dangerous oscillations. This stability has remained constant for billions of years, which has allowed Earth's climate to stay suitable for the slow evolution of ecosystems, and eventually, human civilization itself. The moon's gravitational pull also creates these subtle bulges in Earth's crust, generating heat through tidal friction, and that actually contributes to our planet's internal geological activity. Any changes in the moon's internal structure could, potentially, affect this delicate gravitational relationship over geological timescales. And well, the recent seismic activity suggests that the moon's mass distribution may be shifting as its core undergoes final solidification phases, which could have subtle but cumulative effects on Earth's long-term climate stability, especially through alterations in Milankovitch cycles. Advanced seismic monitoring technology. NASA's next-generation lunar seismometers are about 30 times more sensitive than the instruments used during the Apollo era, and they're designed to detect even the faintest tremors coming from the moon's dying core. Two revolutionary seismic monitoring systems are actually preparing for lunar deployment as part of NASA's push to really deepen our understanding of what's happening inside the moon. Now, the Farside Seismic Suite, or FSS, is scheduled for deployment around 2026, and that'll be the first time humans have ever placed seismometers on the far side of the moon. This will let scientists triangulate seismic sources with a level of precision we've simply never had before. These instruments are honestly exponentially more sensitive than the Apollo devices, capable of picking up tremors that would have been totally invisible to 1970s technology. Meanwhile, the Lunar Environment Monitoring Station, or LEMS, is set to establish continuous seismic monitoring near the South Pole, running for months or even years to capture rare events and build up a long-term picture of lunar seismic behavior. Dr. Mark Panning from JPL says these instruments might finally confirm whether the moon experiences slow quakes like Earth's slow slip events, those gradual energy releases that take days to play out, and could explain that mysterious core signal. Extended observation periods will be absolutely crucial for figuring out whether this recent seismic activity is just a one-off or part of a much bigger pattern in the moon's geological evolution. The lunar core's final chapter. We're living in a rare cosmic moment, witnessing the final geological gasps of a world that's about to become truly dead for the first time in 4.5 billion years. Michio Kaku often points out how incredibly lucky humanity is to exist at just the right moment to observe the moon's internal dynamics before they disappear forever. In another billion years or so, the moon's core will probably freeze solid, ending the geological story that started way back when the solar system was formed. This recent seismic pulse could be one of the last chapters in this 4.5 billion year narrative, which makes our current observations scientifically priceless. Seeing things from this angle really transforms lunar exploration from just curiosity into a sort of urgent scientific priority. We're not just studying a neighboring world, but actually capturing data during a period that will never come again. The moon is giving us a live demonstration of how small planetary bodies evolve and eventually go geologically quiet. These observations are helping scientists understand similar processes on countless other worlds, from Mars to distant exoplanets. And the lessons we learn from the moon's core evolution could be crucial for figuring out which worlds might be habitable and how their geological activity impacts their ability to support life over cosmic timescales. Preparing for an uncertain lunar future. As humanity gets ready to return to the moon after a 50-year break, we're realizing that our closest celestial neighbor still hides some pretty dangerous secrets beneath its familiar surface. The combination of renewed lunar exploration and these surprising seismic discoveries is creating both new opportunities and new challenges for future missions. NASA's Artemis program now has to factor in seismic risks that just weren't fully understood back in the Apollo days, and that means we need thorough geological surveys before we can set up any permanent bases. The recent core signal really adds some urgency to getting those advanced monitoring systems up and running, so we can have early warnings for any dangerous seismic activity. Future lunar settlements are going to need some seriously robust engineering to withstand moonquakes that could last for hours, and even trigger devastating landslides and all that loose regolith. But, these challenges also open up a once-in-a-lifetime opportunity to study planetary evolution as it happens. Michio Kaku's warning is both a heads-up and a call to action. We've got to approach lunar exploration with a lot more respect for the moon's geological complexity. while also seizing this unique window to understand the fundamental processes that shape worlds across the universe. The moon's core might be dying, but its last signals could unlock secrets that totally change our understanding of planetary science and help guide humanity as we move out into the cosmos. Michio Kaku's warning about the moon's core activity really reminds us that even our most familiar celestial neighbor can still surprise us with hidden complexities. As we get ready to return to the lunar surface, these seismic discoveries are going to shape the way we build, explore, and survive on the moon. If you're fascinated by these cosmic mysteries and want to stay updated on the latest space discoveries, go ahead and hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending explorations of our universe. Thanks for watching, keep looking up.